How do protein channels move ions and other molecules across membranes? Channels have a channel, an opening, through the middle that allows molecules to pass. In the case of an aquaporin, which moves water, the channel has charge distributions at places throughout the channel that match the charge distributions on the molecule moving through. In the case of water, the slight negative charge on the oxygen, the positive on the hydrogens, allows the water molecules to fit very precisely in the channel, and so water moves through, and other molecules don't match the size and charge distribution, so they don't move. So water will move through a channel passively. Water will move until the number of water molecules encountering on one side and going through is matched by the number encountering the opening on the other side and moving through. The net movement depends upon how many water molecules are bouncing around inside and outside. But if there are molecules on the inside that attract water, if they're charged, for example, chlorides or sodiums, or glucose, which is a polar molecule, then those water molecules on the inside are not free to move. And so you can have net movement of water in, and each new one that is attracted to one of these interior molecules not being free to move can result in net movement in, even though there's more water inside than out. Many channels are for ions, such as sodium channels, potassium channels, calcium channels, chloride channels. In the case of ions, there's a charge inside, but now a stronger charge to match the ion. And again, the ions are moving passively in either direction. The net movement, whether there's more that happen to be moving in versus outside of the cell, depends upon the charge gradient. If, for example, we were talking about potassium, which is normally in high abundance inside the cell because of the sodium-potassium pump, if we were at 0 millivolts in the cell, then the potassium would be encountering more often on the inside than it's encountering the opening on the outside, and therefore we'd have net movement of potassium out. But as potassiums leave, that's going to start changing the charge. If a potassium leaves, that will make the inside a little bit more negative. We moved a positive ion outside, and so we have a negative 1 millivolt, and eventually we'd get to an equilibrium where the negative charge inside the cell is holding some of these potassiums in place, and so the number free to move and encounter the opening is smaller, and the net movement out will match the net movement in. For charged molecules, what matters is the electrochemical gradient. That's a combination of concentration and charge.